This is Algebra 2, Unit 5, Lesson 2 on arithmetic and geometric sequences. Okay, we talked about arithmetic and geometric sequences back in Algebra 1. Algebra 1 told us, in particular sequences, the arithmetic sequence is based on a constant addition. You add every time to do an arithmetic sequence. A geometric sequence is based on constant multiplying to get the next term. So you're multiplying by the same thing to get the next term. So arithmetic is add, geometric is multiply. So what we're going to look at is review the basics of the two sequences. All right, so let's start with the arithmetic sequence. Its recursive definition said, given f of 1, then f of n equals f of n minus 1 plus d. Or given a1, then a of n equals a of n minus 1 plus d. All right, where d is the common difference and can be positive or negative. So let's break this down. So, given f1, this is always going to be the first term. All right, so it'll be the first term if it's in function notation. This is the first term in subscript notation. Usually at this level you see the subscript, but I'm showing you both terms. All right, so that's the first term of the sequence. All right, now, f of n means the term you're on. Okay, so that's the term you're on, or a of n means the term you're on. Okay, then remember from the previous lesson, what does f of n minus 1 mean? That means the previous term. All right, and this means previous term. Those mean the same thing. Okay, now for an arithmetic sequence, what you'll have is plus d. D is called the common difference. It's what you add each time to get this next term. So you take the previous term and add some number. When it's arithmetic, the d is a common term. It's called the common difference because each term has the same difference between it. So, it's what you add. It can be positive or negative because you can think of it as adding a positive number or you can add a negative number. If you're adding a negative number, you're really subtracting. Okay, so let's see if we can read this. Generate the next three terms of the given arithmetic sequences. F of n equals f of n minus 1 plus 6 with f of 1 equals 2. Okay, so what is the first term of my sequence? Well, according to this, f of 1 equals 2. So if f of 1 equals 2, and I want to find the second term of the sequence, f of 2. Now, according to what this says, if this is 2, this would be 2 minus 1, which would be 1. So this would be f of 1 plus 6. So f of 1, we know, found in the previous term, is 2 plus 6 is 8. So there's the first term. Second term, what would be the third term? All right, well, if this says I'm in the third term, I would need the second term. F of 3 minus 1 is f of 2 plus 6. So this would be, the previous term is f of 2 was 8 plus 6 is 14. All right, and then the next three terms would be fourth term, would be, if I'm the fourth term, I would need the third term. 4 minus 1 is 3 plus 6 would be 14 plus 6, which is equal to 20. So you can see on this one, I had to take each term I was on, start with the first one, take the previous term to it, and add 6. All right, let's try this next one. A of n equals a of n minus 1 plus a half. A of 1 is equal to 3 halves. All right, so again, my first term is 3 halves. Okay, now what does this mean to do? This means to take the previous term and add a half to it. So if I want to find a of 2, I need to know what a of 1 is and add 3 halves to it, or plus half, sorry. Plus a half, not 3 halves. There we go. Okay, so a of 1 was 3 halves, plus a halves is 4 halves, or 2. Okay, so the third term of the sequence. If I want to find the third term, I need to know the previous term, which would be a of 2 plus a half. The previous term was 2 plus a half is 2.5. And the fourth term of the sequence, if I'm on the fourth term, I need to know the previous term, which would be the third term, plus a half. So it would be 2.5 plus a half is equal to 3. So you can see, if you read the notation, in order to figure it out, it tells you exactly what to do. You just have to be able to interpret either if it's in function or subscript notation. All right, let's try this one. For some number t, the first three terms of arithmetic sequence are 2t 5t minus 1, and 6t plus 2. Okay, what is the numerical value of the fourth term? So we are looking for this term right here. That's what we are looking for. So first of all, what we need to know is what are the terms of the sequence and how do they go up? Well, remember, this is an arithmetic sequence. All right, if it is the arithmetic sequence, it means that you're going to add or subtract each time. So, and it is what's called the common difference is going to be the same. So you're going to add the same value each time. Okay, so the common difference is going to be between here and here, and here and here, and here and here should all be the same. So we have to figure out what is the common difference. So to figure out the common difference, all you have to do, if you're adding this way, wouldn't you subtract going the other way? So to figure out the common difference, you take two successive terms and subtract them. So it would be, for example, a2 minus a1. Okay, so let's figure out the common difference between here and here. So I'm going to take 5t minus 1 minus 2t will give me the common difference. This would be d right here. All right, so if I simplify that, that's going to give me 3t minus 1 is equal to d. So this value right here, I'm going to add 3t minus 1. Okay, now what do I have to add here to here? Well, let's see, I'm going to subtract so I can figure it out. 6t plus 2 minus 5t minus 1. 6t plus 2 minus 5t plus 1, make sure you can distribute the minus to the parentheses, should equal d. So your difference here is going to be t plus 3. Okay, now since this is a common difference, these two differences should be the same. So set them equal to each other. 3t minus 1 is equal to t plus 3. Solve for t. Subtract the t here. That's going to give you 2t minus 1 is equal to 3. Add the 1. 2t is going to equal 4. So that makes t is equal to 2. Okay, so what does that tell us our common difference is going to be? Our common difference is going to be 5. 3 times 2 is 6, plus 1 minus 1 is 5. T plus 3 is going to be 2 plus 3 is 5. So that means I'm going to add 5 here as well. Okay, so let's see what our terms are. My first term of my sequence, 2t, is going to be 4. All right, now in my second term, if I did it correctly, it should be added 5, should be 9. Let's see. It would be 5 times 2, 5t minus 1. 5 times 2 is 10, minus 1 is 9. And then 6t plus 2 would be 6 times 2 is 12, plus 2 is 14. Notice here, each one of these is going to be adding 5. So what should be the fourth term? The fourth term, adding 5, should be 19. Okay, so the common difference means it is adding the same thing each time. To figure out what the common difference is, you subtract the successive ones. So if you're going this way to add, you would go this way to subtract to figure out which way you want to go. All right, so it is important to be able to determine a general term in an arithmetic sequence based on the value of the index variable or the subscript. So we want to be able to figure out a formula for any term of the sequence. So let's consider a of n equals a of n minus 1 plus 3 with a of 1 equals 5. Determine the values of a2, a3, and a4. All right, so we know a1 is 5. If I want to find a2, what does this say to do? All right, remember if this is 2, this would have to be 1. So we take the previous term, a1, and add 3 to it. So this is going to be 5 plus 3, which is 8. So the previous term to a3 would be a2, add 3 to it. a2 is 8, plus 3 is 11. And then a4 would be, the previous term would be a3 plus 3, 11 plus 3 is 14. So there's my terms of my sequence. All right, now, how many times was 3 added to 5 in order to produce a4? All right, well, we started here and get to here. How many times did we have to add 3? All right, so we started from here. We had to add 3 times. Okay, so that means because we're starting on the first term, to get to the fourth term, we had to add 3 one less time than the term number. The term number. Okay, if we want to go to the fourth term, we need to add 3 three times. Okay, so use your result from part B to quickly find the value of A50. If I wanted to find the 50th term of the sequence, okay, I started at what value? I started at A1, and I wanted to add 3 how many times? Well, if I'm starting on the first term and I want to go to the 50th term, I have to add 3 49 times. All right, so A1 is 5, and then 3 times 49, 5 plus 3 times 49, times 49 is 152. So, A of 50 is going to equal 152. So what you want to add here, your common difference, is always going to be 1 less than the term that you're on. So A of 50 will be 152. So write a formula for the nth term of an arithmetic sequence A of n based on the first term A1, D, and n. All right, so that's going to be A of n, to find any term, would be the first term, A of 1, plus whatever your common difference is, n minus 1, times. So it'd be how many times you want to add it, or add is going to be 1 less than whatever term number that you're on. Now that's an important formula. It's even on the Regents reference sheet, which I'll show you later. All right, let's save exercise 4 for the next class, and we'll move right on to exercise 5. So we'll save this one and move on. Geometric sequences are defined very similar to arithmetic, but with multiplicative constant instead of additive one. So instead of adding every time, notice here you're going times r. So you may see it either way, times r. R is called the common ratio because you are multiplying by the same thing every time. So to multiply every time, generate the next 3 terms of the sequence. A of 1 equals 4. R is equal to 2. R is the common ratio, means you're multiplying every time. So this says take the previous term and multiply by the common ratio. So A of 2 would be A of 1 times 2. All right, A of 1 is equal to 4 times 2 would be 8. A of 3, take the previous term, which would be A of 2, multiply it by 2. So that's going to be 8 times 2, which is 16. And then A of 4, take the previous term, that's what n minus 1 means, would be A of 3 times 2, would be 16 times 2 is 32. Okay, so all this means, same thing as with addition, take the previous term, but instead of adding, you multiply. All right, so f of n equals f of n minus 1 times the third with f of 1 equals 9. This is the first term, is 9. Your second term, what does it say to do? Take the previous term, multiply by a third. So this is going to be f of 1 times a third. So f of 1 is 9 times a third is going to equal 3. All right, f of 3, the third term of the sequence, would be the previous term that you're on. This is third, so we need the second term times a third. So this is going to be the previous term is 3 times a third is 1. And f of 4 is going to equal the third term with the one previous times a third. So it's 1 times a third, which is a third. Okay, so you can see the only difference is you're going to be multiplying instead of adding. All right, let's do one more. T of 1 equals 3 radical 2. T of n minus 1. T of n is equal to T of n minus 1 times the square root of 2. All right, so if the first term is 3 radical 2, the second term is going to be the previous term, T of 1, times the square root of 2. So this is going to be 3 radical 2 times radical 2, which would be 3 radical 4, which is 3 times 2, which is 6. All right, T of 3 would be T of 2 times radical 2. So this is going to be 6 times radical 2, which is 6 radical 2. And then T of 4 would be the third term times radical 2. So it would be 6 radical 2 times radical 2, which is 6 radical 4, which is 6 times 2, which is 12. And like arithmetic, we also need to be able to determine any given term of a geometric sequence based on the first value, the common ratio, and the index. So let's save the rest of this for the next class, and we'll go over geometric sequences some more.